Hello all. In this presentation, we are going to discuss an important topic in concrete technology, quality of water used in concrete. Although water appears to be a simple ingredient, it plays a vital role in determining the strength, durability and performance of the concrete. Even if we use high quality cement and aggregates, poor quality water can reduce the quality of the concrete produced. Therefore, understanding the requirements and quality of water is essential for all of us. Let us first understand why water is important in concrete. Water performs two major functions. First, it reacts chemically with the cement through a process called hydration, which allows the concrete to harden and gain strength. Second, water provides the necessary workability, making it easier to mix, transport, place, compact, and finish concrete. Without sufficient water, hydration cannot occur properly, while excessive water reduces the strength of the concrete. Therefore, both the quality and quantity of water are equally important. So, requirements of water for concrete mixing. According to IS 456-2000, the Indian Standard Code, and ASTM C1602, the American Standard, water used for concrete should be clean and free from harmful impurities. It should not contain excessive amount of silt, clay, oil, acids, alkalis, salts, organic matter or vegetable materials. These impurities interfere with the hydration process and reduce the quality of concrete. In most cases, in almost in all cases, potable or drinking water is considered suitable for making concrete. A simple rule is that if the water is fit for drinking, it is generally fit for concrete production. The pH value of water should be greater than 6 and preferably between 6.5 and 8.5 to ensure proper hydration without causing harmful chemical reaction. Water is mainly used in two stages of concrete work. First is mixing water, which is added during the preparation of fresh concrete. Second is curing water, which is applied after placing the concrete to maintain moisture and ensure hydration, complete hydration. Curing water should also be clean because if you are using contaminated water, it can leave stains, deposits, or harmful chemicals on the concrete surface. So next, why water quality is important. If water contains impurities such as sugar, oils or excessive salts, it can either delay or accelerate the setting time of cement. This affects the normal hardening process and may reduce the final strength of the concrete. Harmful chemicals present in water can also reduce the bond between cement paste and aggregates. Another problem, serious problem, is corrosion of steel reinforcement. Chlorides present in the contaminated water attack the steel bars, embedded steel bars in concrete, causing rust formation. As rust expands, it creates internal pressure, leading to cracks, spalling of concrete cover, and ultimately reducing the service life of the structure. Water containing excessive dissolved materials may also produce efflorescence, which appears as a white crystalline deposits on the concrete surface. This mainly affects the appearance. It also indicates the movement of salt through the concrete and may be associated with durability problems. To ensure that water is suitable for construction, we are performing water quality tests. First is chemical analysis, where the water is tested for chlorides, sulfates, pH value, suspended solids, and other impurities. Another method is important method is comparative strength test. In this test, 3 concrete cubes are prepared using the test water, and another 3 cubes are prepared using distilled water. The compressive strength of the cubes made with test water at both 7 days and 28 days should be at least 90% of the strength of the cubes made with distilled water. If this condition is satisfied, the water is considered suitable for concrete making. According to Indian standards, the permissible limits for impurities are also specified. Organic matter should not exceed 200 milligrams per liter, inorganic matter should not exceed 3000 milligrams per liter, sulfate should be limited to 400 milligrams per liter, chlorides should not exceed 2000 milligrams per liter for reinforced concrete, and suspended matter should also remain within the specified limits. Let us discuss the use of seawater in concrete. Seawater contains we know that seawater contains large quantity of dissolved salts. The major constituent is sodium chloride, along with smaller quantities of magnesium chloride, magnesium sulfate, calcium sulfate, and other dissolved minerals. These salts create several problems if it is being used in concrete. The first and most serious problem is corrosion of reinforcement. Chlorides present in seawater accelerate corrosion of steel bars, causing cracks and spalling of concrete. And sulfates and magnesium salts react with hydrated cement compounds, reducing durability, causing expansion and deterioration over time. Another common problem is efflorescence, where salts migrate to the surface and leave white deposits, affecting the appearance of the concrete as well as appearance of the structure. According to IS 456-2000, seawater should never be used for reinforced concrete, pre-stressed concrete, or concrete with embedded metal, because the risk of corrosion, because of the risk of the corrosion. However, seawater may be used for plain concrete under controlled conditions, provided total chloride content remains within permissible limit. When construction must be carried out in coastal or marine environments, certain precautions we have to follow if we are using seawater. We must use sulfate resist cement, provide greater concrete cover to reinforcement, apply protective coatings or corrosion inhibitors on steel, and incorporate pozzolanic materials such as fly ash or silica fume to reduce the permeability of concrete. In critical structures, accelerated corrosion tests must also be conducted to evaluate the long time durability. In conclusion, we can say that use of seawater for concrete should be avoided. Potable or drinking water quality is most suitable for making concrete. Thank you.